Okay, so going through the questions from the last worksheet, we had these last two to finish off. So a cyclist maintains a speed of 25 kilometers per hour. How long will it take for them to travel 75 kilometers? We have our equation, t equals s divided by v. We identified our variables. We plugged them in. We should get 3 hours. Now we can leave that in hours because that's what our unit was originally in. Next, if a boat travels at a speed of 30 meters per second and travels for 5 minutes, how far does it go? We've got a new equation, s equals v times t. Find our variables. Here we have to make sure we change 5 minutes into 300 seconds. So we've got 30 times 300. We end up with 9,000 meters or 9 kilometers. Either answer is okay. Then was the final question, which is a car traveling at 26 meters per second. Speed limit is 80 kilometers per hour. State if the car is exceeding the speed limit. So we can start with 26 meters per second, and we need to change that to kilometers per hour. So I've started here, 26 meters per second. So I need to times that by 1 kilometer divided by 1,000 meters. The meters cancel out. So I end up with 26 divided by 1,000, which ends up as 0.026 kilometers per second. Then I deal with the seconds. And here we've got 0.026 kilometers per second times 3,600 seconds divided by 1 hour. Those seconds cancel out. So you end up with 0.026 times 3,600. So we end up with a speed of 93.6 kilometers per hour. So 93.6 is bigger than 80. So yes, they are speeding. So I'll just show you that whole sheet just so you can mark yours and make sure you got everything down. Okay, now we've finished speed. We want to look at distance time graphs, and this is our kind of next thing that we move on to. So we've got a distance time graph here. Remember, on a distance time graph, S is distance, okay, and T is time. Okay, measured in seconds, and then normally measured in meters, but it can be kilometers or whatever other unit. Now, when we look at a distance time graph, we start to look at the shapes that we make. So we can see here we've got a straight line. Let's use blue for that. It's got a straight line that goes up, okay, up here. And then we've got this kind of line that's going across, okay, and down. Rub that one out, that was really bad. And goes down here. Okay, and then we've got this other line, let's use red, goes straight across here. And we can describe the shapes of these graphs. Now, just before we do that, we need to think about the gradient and what's the gradient telling us on a distance time graph. So if we think back to our kind of standard kind of maths lessons, we know that y equals mx plus c. Okay, for a straight line, this is our equation. Now, if we look at our graph, sorry to jump around, we see this intercept is always at 0. We always start at 0. So this just becomes y equals mx. Okay. Now we put it into terms of our graph. On our y-axis, we have distance, and on our x-axis we have time. So if we want to work out what m is, m equals y divided by x, or m equals distance divided by time. And now from the last lesson that we just went through, we should remember that distance divided by time equals speed. So m is speed. So on a distance time graph, the gradient or slope shows us the speed or velocity of the object. Now that could be a car, could be a bike, could be a person walking, doesn't really matter, but it's showing us the speed or the velocity. So now when we talk about these shapes, if we think about this blue line to start with, we can look at this and we could say, well, that gradient is quite high. We don't have any numbers on here, but we could say that has quite a high gradient. So we could describe this as a high speed. And if we think about our 0 down here as our starting point, this is moving away from that starting point, away from the origin. Okay, and actually, if we think about this, if we think about that gradient, it's got a constant gradient. So what we could actually do is change this to say it is a high constant speed away from the origin. So we've got a high constant speed moving away from the origin. Now, we could also say that's the same for this yellow line, but it's a bit lower, so it's not a high. We're kind of, high is relevant here. But this red line, if we're talking in terms of compared to that blue line, we could say this is a low constant speed, also away from the origin. Okay. Now, let's go to this middle box here, this middle yellow one. Now, think how we could describe that middle yellow one. So if we think about the gradient, if we worked out m here, m would be 0, which means this object has no speed or no velocity. So we could say this is stationary or at rest. It's not moving, basically. There's no movement happening there, so it's stationary or at rest. Both of them mean the exact same thing. Then if we look at this last one, we can go back to saying, and comparing it kind of relative, to the blue line and the red line, I would say it's fairly high speed. So we could say it's high, once again it's constant speed, but this time we're going back to this original line, okay, because remember this is 0, we're going 0 meters, so we're going back to this original line, so it's towards the origin. Okay, now there's one more that we could describe. We'll come back to that in 1 second. Let's talk about this total distance over here. So if we want to know the total distance traveled for this yellow line, okay, we would need to work out, I'm just going to do this in green. So we would need to work out distance traveled at A. So it'd be from 0 to, let's just put a number on this. Let's just say that's 10 meters. So we say that's 10 meters. At this point here, we're stationary, so we're traveling 0 meters, and this would be B. And here we've traveled another 10 meters, but now back to the origin, 10 meters. Let's call that C. So if we want to know the total distance traveled, total distance is add up all distances along the line. So if we're looking at that yellow line, be A plus B plus C. So in that case, for the yellow line, it would be 10 plus 0 plus 10, 20 meters. And you would just do that for any of them. So if we were to look at, like, let's say this blue line, we would just count up. Now there's no actual scale on here, but you would just count up, see whatever this is here, and you'd be able to work out the distance. Now I said there was one more line that we could look at. Now if I just choose a color so we can see it. and that is if the line curves. Okay. Now, a curved line or curved line shows a change in speed. Some of you might already know what that's called, and we're going to do the next lesson on this. This is acceleration. Okay, and that's a change in speed over time. I'm going to talk about that in the next lesson.